Okay, so I'm going to kick off there now. So thanks everybody for joining today. We're going to be going through a couple of topics here, but the main one we're going to be talking about is mastering 6.4.3 and 11.6.1 and how that could affect your PCI compliance. And we have a couple of guys here from Jscrambler, one of our partners, who are going to be assisting you in going through with that. We have two speakers with us today. We have John Elliott, a security advisor from Jscrambler. We've also got Gareth Bowker as well, from a technical advisor from Jscrambler. And just a few housekeeping rules to go through. The webinar will take about approximately 45 minutes or so. If you look at the bottom of your screen there, you'll see a chat box function. You'll be able to post questions in the chat. Anything you want in there, just let us know. We'll be happy to have a Q&A at the end to go through, or if you want during the presentations, if you have any questions to go through, I'm sure John or Gareth will be more than happy to go through them with you. We'll give a presentation, and then at the end, there's going to be a demonstration to go through some of the functionality of Jscrambler and how that could potentially work for you as well. Once we're finished, all the registrants will receive an email with a recording of the webinar as well. So you'll be able to listen back on that if there's any of the points you want to go through again. And of course, obviously, if you have any questions, you can reach out to myself or to the guys at Jscrambler directly, and they'll be able to assist you. So our agenda today, we're going to go through a welcoming introduction with the guys. We're going to talk about the challenges with PCI DSS 6.4.3 and 11.6.1. We'll also be addressing the PCI DSS requirements and accelerating compliance, and the demonstration will be on that as well. We'll have a Q&A where hopefully any and all questions you have, we'll be able to go through and answer for you there. And then we'll have a closing remarks and go through the next steps and what potentially this could mean for you and how we can assist you in becoming PCI compliant as well. So just from my own standpoint, my name is Andrew McCarroll. I manage the PCI level 1 to 3 compliance program for Elavon. And today what we're going to go through, we're going to an overview of what has changed in PCI DSS version 4. We're going to look specifically at the changes and the challenges around 6.4.3 and 11.6.1. We'll run through the timeframes of the now fully defined version 4 and what they might mean for the frequency control activities are performed, what these changes mean for you, and how Elavon and Jscrambler can assist in removing these potential pain points. We have two fantastic speakers, I must say, from Jscrambler today in John Elliott and Gareth Bowker. John is a specialist advisor in regulated security and data protection. He has represented both MasterCard and Visa on the PCI security councils, and he has contributed to many PCI standards, including the current version 4. So we have him to blame for a couple of these pain points as well, but thankfully he also has solutions for them. Gareth has been involved in the payment card industry for about 20 years, I think it is, Gareth. You've also served with the council themselves. You were a director of training there, and he was responsible for the PCI Council's information security and PCI DSS compliance. So we'll finish with a summary of the key points to remember and some recommendations that will help make sure you're ready for your assessment for using PCI DSS version 4. So with that, I'm going to hand off to the first of our speakers, Mr. John Elliott. John?
Good. That's great. Thank you, Andrew. And let me see if I can manage to share my screen successfully, which is always the hardest thing to do when we're doing one of these presentations. And so hopefully, can someone just tell me that worked? Cool, brilliant.
Yeah,
thank you.
Working.
And thank you for the kind introduction. So yeah, I have to admit to a degree of responsibility, because I was MasterCard's rep when we wrote version 4. But then, I can take responsibility for the things that are not in PCI DSS, where I would argue that was a thing too much and we shouldn't put that in. So it's like taking responsibility for things you'll never see. Anyway, where are we? So let's go through as Andrew said, let's quickly go through the timeline first. So DSS 4 came out in April 2022. It was mandatory from 1st of April 2024, and the new, what we used to call future dated requirements, but now best practice requirements, became mandatory on the 1st of April 2025. So there was 3 years to implement any new technical requirements, any requirements that will require you probably to go out and either buy or make a solution. And the reason for that was very clear, in that the council wanted to give everyone enough time to secure budget, secure a change window, and work out what would work in their environment. So I'm going to start actually answering a question that people ask me a lot. They all say, when do we need to comply with those new requirements? And there are two answers you will hear. Either that all those new requirements need to be in place on the needed to be in place because we're past the 1st of April. All those new requirements needed to be in place by the 1st of April. All they need to be in place for your next assessment. Now, contractually, your contract with your acquirer, which I presume is Elavon, will say you need to comply with the current version of PCI DSS. So technically, you should be compliant with those new requirements now, but most people wait until their next PCI DSS assessment. In fact, speaking to a lot of QSAs, they were really busy in February and March this year for some unknown reason, that everyone seemed to have brought their assessments forward. So I guess that's a big thing. I'm going to ask a quick question. I think hopefully we can put a poll up. Like, how many of you worked out what you're going to do for 643 and 1161? Can we put that poll up now? Okay, I can see it. So have you selected something to do for 643 and 1161 already? This is anonymous, okay? Like, we have no idea who's answering. All we know is how many people have answered it, okay? I think that's a pretty good representative. Oh, no, it's I was about to say that's a really good representative sample, and now it's changing. I'm not sure if we're going to display a sexy graph at the end of this, or if you can all see the graph. So I'm gonna read out the results, which is that half the people are deciding. About 30% have decided and 20% haven't decided at all. But hopefully those people who haven't decided will still move into the currently deciding phase by the end of today. Okay, that's great. Thank you very much for that feedback. Oh, no, I can press share results and maybe you can all see. There, isn't that magic? You can tell I'm practiced at using Zoom. Not practiced at using Zoom at all. Okay. Great. So let's quickly go through the two requirements. The first requirement, 6.4.3, is about managing payment page scripts. So that you have to have an inventory of them. You have to write a justification of why they're necessary. You have to confirm that each script is authorized. You don't have to pre-authorize the scripts. You have to confirm that each script is authorized, and you have to have a method to ensure the integrity of each script. So this is to make sure that scripts are effectively managed. One of the problems we found with compromises before version 4 is merchants didn't know what scripts were on their website. And so the idea of 643 was to make sure that you knowingly put a third-party or a first-party piece of JavaScript on your website, rather than it just like happening to appear one day and nobody knew where it came from or who owned it. Then 11.6.1 says, look, let's assume that there will be changes that are unauthorized, i.e. you haven't authorized it, but a change happened or a new piece of script appeared. So you need to be able to detect that and then do 643 to make sure that that changed JavaScript or that new JavaScript was knowingly on your web page. So those are the two requirements, and they apply to a payment page. And a payment page is handily defined in the PCI DSS glossary, which you'll find in Appendix G, as a web-based user interface containing one or more format elements intended to capture account data, which is presented as a single document or instance. So like you control the form that gets the cardholder data, or is displayed as a document or component in an inline frame, in an iframe. So typically you load the iframe from the payment service provider. You're in charge of the bit that's in pink. The payment service provider is in charge of the bits in blue, which is the payment page. And for a lot of people now, that's supplied as multiple iframes. So you'll have a separate iframe for each field on the payment form. So you can still make it look pretty, but the PSP is responsible for the collection and receipt of cardholder data. So that's what it applies to. But then PCI DSS 4.0.1 was released in, from memory, about April, I think, February, March, April last year. And PCI DSS 4.1 extended this requirement into the parent page, the page that hosts the iframe. It's written in probably some of the worst language. I was going to say the worst language, but we are actually going to come to the worst language the PCI SSE has ever used. So we'll come to the second worst language. It says, so this requirement also applies to scripts in the entity's web pages that included TPSP's payment processor embedded payment page form, for example, in an iframe. So now the requirement applies to both the parent page, which is hosted by the merchant, which is in pink, and the PSP's payment page. Both of them have to comply with those two new requirements, 643 and 11.61. And that was all very clear in about, February. And then January this year, I think it was the 30th or 31st of January, SAQ A was revised. And the revision to SAQ A was that 11.61 and 643 were removed from SAQ A. And typically SAQ A is used by merchants that use a PSP's iframe, as long as the merchant can confirm that their site is not susceptible to attacks from scripts that could affect the merchant's e-commerce systems. This is probably the worst bit of writing the PCI SSE has ever made, because I have no idea what a site is, what not susceptible is, to what type of attacks, from what sort of scripts that could affect in what different way the merchant's e-commerce systems. This is the waffiest thing I think the council's ever written. But that now means that the responsibility for 643 and 11.6.1 looks like this. The PSP, if you're using a payment service provider's iframe as part of your payment solution, the PSP still needs to meet 643 and 11.6.1. The merchant just needs to confirm their site is not susceptible to script attacks, right? And so, as I've said before, I think actually this has got a lot of words in it that really don't mean things that in the way that the council has clearly defined things. Maybe they vagued it up so you could interpret it however you wanted. Anyway, to try and decipher this, I had to do a flow chart. You can tell it's getting complicated when you have to write a flowchart to understand how the standard works. So here's my really simple flowchart. Do feel free to get this recording and take a copy of this flowchart if you need to explain it to other people in your organization. Like, don't worry about stealing the flowchart idea. So the question starts with, do you have a payment page? And if you do, that's really simple. You need to meet 643 and 11.6.1 for the payment page. If you don't have a payment page because you're using a PSP's payment page hosted in an iframe on your site, we then get to a next question is, are you doing an SAQ, typically SAQ A, or are you having an assessment with an assessor to produce a report on compliance? Because if you're doing an assessment for a report on compliance, you still need to meet 643 and 11.6.1 because those requirements are in the main standard, which you'll do for your report on compliance, and they apply to the parent page. But if you're doing SAQA, all you need to do is confirm that your web page is not susceptible to attacks from scripts that could affect the frames. Quite hard to do that technically, but that's what you need to be able to do. And if you're doing SAQA, you can probably just tick the box, which is what people who do SAQs do. Okay, but there is a really, really strange wrinkle, because there's an FAQ 1331 that says merchants that have environments that fully meet all the eligibility criteria defined in a particular self-assessment questionnaire may use that SAQ as a reference to identify what PCI DSS requirements are applicable. And then when it's assessed, the assessor will verify that you meet the eligibility criteria. So I need to change my flowchart. So again, we'll stop at that. We've got halfway here. So if you're doing SAQA, you confirm you're not susceptible. If you're doing a ROC, you now have to say, am I doing a ROC and following FAQ 1331? Because if I am, now I can just follow the requirements in SAQA if I can confirm that my site is not susceptible to attacks from scripts. Again, quite a hard thing to be able to confirm, especially if you actually ask someone technical or your legal department, but that's what you have to do. Otherwise, you have to meet 643 and 11.6.1 for the parent page. So now this is all, we're probably at the middle of February, and this is really clear as mud, really, let's be honest. And so because it was so badly worded, the PCI SSC now issued FAQ 1588 at the end of February to confirm, to explain how you can confirm that your site is not susceptible to attacks from scripts that affects the merchant's e-commerce system. And if this is the first time you've seen this FAQ and been shown this flowchart, and your head is about to explode on the next slide, don't worry, because all of ours did at the same time. Because one of the ways of FAQ 1588 says there are two ways you can confirm that your web page is not susceptible to script attacks. You could use techniques such as, but not limited to, 6.4.3 and 11.6.1. So you could still do 643 and 11.6.1, and then you could confirm that your web page is not susceptible to script attacks, or you can get confirmation from your PCI DSS compliant third-party service provider or payment processor, or PSP, that their embedded payment forms, when implemented according to their instructions, include techniques that protect the merchant's pay from script attacks. So you can either do 643, 11.6.1, or you can ask your PSP if their iframe is immune from attacks from scripts. So So basically, you've got this option or this option. So let's change the flowchart. I did this flowchart before this FAQ 1588 came out, so now I have to I have to shrink it down a bit. Okay, so we're now in our eligibility criteria where we're confirming we're not susceptible. So now we look at 1588. So one option for 1588 to confirm we're not susceptible is we can do 643 and 1161. So we end back at doing 643 and 1161 for the parent page. Or if not, we ask our PSP, we say to our PSP, can you confirm that your scripts make it so that your fields are not susceptible to script attacks? And they've got two options, of course. If they say no, you're back to doing 643 and 1161 for the parent page. If they say yes, we now need to work out if you're doing an SAQ or a ROC. If you're doing an SAQ, that's done. You don't have to do any more. If you're doing a ROC, your QSA needs to validate the confirmation that the PSP gave you. And I'm really sorry that to meet two new requirements, we ended up with a flowchart with what, 1, 2, 3, 4, 6 different decision boxes and a number of different places you could end up. And again, feel free to steal this and use it in your own presentations. At the same time as doing all of this confusing changing of FAQs, the council also issued this really helpful document called Payment Page Security Preventing E-Skimming Guidance for PCI DSS Requirements 6.4.3 and 11.6.1, which doesn't mention really anything to do with these new FAQs, but it actually tells you how to meet 643 and 1161. It is a very good document. I wrote most of one of the sections. My colleague Pedro Fortuna, our chief technical officer, wrote almost all of another of the things. It was a collaborative, industry-wide group of people helping to write this document that was then edited by the council. It's actually not a bad document, but it's 25 pages long. I want to very quickly talk about how to operationalize anti-skimming requirements. Now, what I mean by operationalizing is Gareth and I have seen lots and lots of organizations that have tried to meet 643 and 1161, and I want to share with you some of our experience of what can go wrong. And the first thing is I'm going to look at 643 mostly because this is where most problems are. And the first thing is to look very carefully at the language. You need a method, you need an inventory of all scripts with a justification of why each is necessary. A method to confirm that each script is authorized. It doesn't say authorized by who. It could be authorized by policy, it could be authorized by a person, it could be authorized by a process. And then a method to assure, not ensure. Be very careful about the words. We wrote the words very carefully. A method to assure the integrity of each script. In other words, how do you get assurance that the script is not malicious? And you need to do this at 2 times. Firstly, when a script is added to a page, and secondly, when a script changes. And what we've found with organizations trying to implement these requirements is the danger is you get change fatigue because the JavaScript on payment on web pages now changes a lot. So for every change, you need to authorize it, update the inventory, and write the justification. That creates a what we call a signal to noise ratio problem. And there are lots of changes. And if you're following all of those changes, then the danger is you may miss a risky change. And so actually, it just becomes someone doing tick box compliance. And so if I'm talking about change, let me be very clear. Change can happen change and script changes can happen in 4 places. Firstly, for new first-party scripts that come from domains that you control, normally you can manage new scripts appearing under your existing change control process. You might, if you have a really good change control process and a good CI/CD pipeline, be able to meet those requirements because your CI/CD pipeline and your change control process picks up the change before it happens. When it comes to third-party scripts, that's scripts that come from domains you don't own, such as Google Tag Manager, lots of other places on the internet. The first challenge you have is to work out how many people can add scripts to the site. If they're using a tag manager, that could be an awful lot of people in marketing and digital departments. So that's a business process problem. But the really largest operational impact we've seen is when you have a lot of third-party scripts that you're not part of any third party's change control process. So those third-party scripts will change in when the third party wants. That's then an unauthorized change that you have to pick up and detect with 1161 and then make it an authorized change by working out, well, is it the same script? Is it still authorized? Are you still happy with the integrity? Is your inventory correct? Is the justification correct as to why the script's necessary? Is it doing the same thing? Which gives us basically a number of scenarios. So if you've got a lot of all first-party scripts, then your operational challenge increases quite slowly as the number of scripts increases. If you've got a mix of first and third party, it increases quite quickly as the number of scripts increases. And if you've got mostly third party, the operational challenge makes it almost unfeasible from the start. And so remember, what I was talking about is that when a new script's added to the page, what you need to do is, our experience is work out what that script does, work out if it has some explicit integrity. For instance, scripts that come from Elavon have implicit integrity. They're your payment service provider. You probably don't need to work out how to assure the integrity of that, because you've got assurances that Elavon is a regulated financial company. They're regulated by the FCA. They're PCI DSS compliant. You probably don't have to worry about their scripts, because let's be honest, if Elavon's payment page scripts get compromised, there's a bigger problem than you. And then, like, is the script one that you know? Can you automatically add it to the inventory? So how much can you automate this? And then when a script changes, like, you need to say, is it still an authorized script? Is the integrity assured? Well, if Elavon changes their script, the integrity probably is assured. You probably don't need to worry about that. But when different levels of types of script have different level of inherent assurance, and the big question we ask ourselves is, did the script change its behavior? Because if it didn't change its behavior, if it's doing exactly the same sort of things, you can probably assure the integrity because its behavior has not changed. You can authorize it based on a policy decision and automatically update the inventory. Whereas if a script did change its behavior, then you probably, can you assure the integrity? You could probably do some tools to assure integrity, but you might want to say, well, it changed behavior. We need to review the reason it's on the page and get a new authorization. And so behavioral monitoring of scripts, I think, is actually the way to make sure that you can manage your website and comply with these two requirements. So look, in summary, it depends on what type of organization you are and how you have different first and third party scripts on your website and how many you have. If you have a lot, it becomes hard to manage the operational challenge. If you've just got a few first party scripts, you can probably manage this really easily using something called content security policy. And remember that you can have different ways of providing assurance. Remember, it says assure, not ensure. Different ways of assuring different scripts integrity. You can get assurance of the integrity of Elavon's payment page scripts because they come from your payment service provider. If you've got a fair number of scripts and a mix, then our advice is before you buy a tool is to benchmark your rate of change. How quickly do you add new first party and third party scripts to your site? How often do they change? What can you do in your organizations to reduce what I call busy work, that authorization, justification, and inventory? That's compliance busy work. How can you automate as much of that as possible? And then finally, if you are this type of person, you're going to need to buy a tool. Without a doubt, if you've got a lot of third-party scripts on your site, you're going to have to buy a tool to manage them. It's almost impossible to do it with the embedded content security policy and sub-resource integrity. There are now lots of tool vendors. When these requirements came out, there were probably about 2 or 3 tool vendors, now probably 15 tool vendors. Obviously, I'm going to say Jscrambler is really good, which it is really good. It will do the behavioral monitoring. Gareth's going to show you that in a minute. We have a managed compliance or a delegated compliance product, which can get you compliant within 24 hours. And although the standard doesn't require it, what we can also do is block all JavaScript access to payment fields so that if anything goes wrong, we can stop a piece of script trying to take cardholder data or actually any data such as login information or passwords. So if this is you, you will need a tool, but do that benchmarking of understanding who can change scripts and how frequently scripts change in your organization. And now I'm going to hand over to Gareth, who's going to talk about web page integrity. Thank you, Gareth.
Thank you, John. Right, so there are a few little topics that I was hoping to cover today. And let me just share my screen. I'll get myself logged in and we'll get started. So I'm just going to pull up web page integrity. So this is Jscrambler's solution for meeting requirements 643 and 1161. So web page integrity is actually it's a very large solution. It was originally built before these PCI DSS requirements came out, and it was built to, if you remember, going back about 5 or 6 years now, there were issues with things like I think it was Facebook Pixel and so on, where they were accessing elements of personal information on sites when they really shouldn't have been doing that. So web page integrity as a solution was built to try to monitor, first of all, and then prevent these third-party scripts from being able to access sensitive information. When the PCI DSS version 4 requirements came out around 6.4.3 and 11.6.1, Jscrambler realized that web page integrity was around about sort of 95% of the way towards meeting those requirements already. And so what they did was they added some additional functionality to meet the requirements in full, and then they also pared down the full web page integrity tool into a PCI DSS module. And that's what I'm going to be showing you today. So just starting here with our dashboard. So it gives you a nice sense of where things are up to. We can see here that we've got, in total, there are 13 different vendor services that are running on our e-commerce site. You can see we've got 11 of them that have previously been authorized, and there are 2 here that are in needs review. That means, in this case, there's actually one new piece of JavaScript that's been added into the site, and there's actually one as well that has changed since it was previously authorized. These vendor services, this is what we call the JavaScript vendors that map onto PCI DSS Requirement 6.4.3. And then we also have another section for HTTP headers, and this maps onto the HTTP header section in Requirement 11.6.1. We also have within our solution the ability to detect skimmers. So John talks a little bit about this. What web page integrity does is it looks at the behavior of the JavaScript that's running in the page. It also goes a step further, and it does a static code analysis looking for anything that looks like a skimmer as well. And so here we can see that in one of these JavaScript vendors, we've got a potential skimmer found. We can go in and have a look at that in just a second. The final thing I want to show you on this overview page is this little section down here called Evidence for Assessment. So for those of you that are having either an on-site assessment with a report on compliance, or maybe you're using an ISA to do internal reporting, you'll need to be able to collect evidence to be able to give to the assessor. And this is what this section is here. It allows you to download a CSV file that contains all of the authorizations, all of the justifications, all of the new JavaScript changes to JavaScript and so on for vendor services. The same thing for HTTP headers. And then for alerting as well. So anytime we detect a change, we send out an alert, and you can get that as well. So you can see that, you know, when an alert goes out, you can see the response time before something is then reauthorized. So one final thing I want to mention about web page integrity before I dive into these 2 sections. There's actually 2 different ways that we can deploy web page integrity. The first is as a scanner, essentially. So we call this our agentless deployment. What this does is it runs from our systems, it navigates to your website, it goes and navigates however is necessary to get to the payment page, and then it looks at the JavaScript that's running within that page at that point. So we get a full set of the behaviors of all of the JavaScript and how it's running on your page. And this really requires no changes from your side. Okay, I see there's a hand up from Christian, so let me just see if we can get I don't know, can somebody get either Christian's question, or can we get him to speak on this? I tell you what, Zoom is not letting me see any typed questions right now. So I don't know, John or Andrew, if there is a typed question, if you want to jump in with that. Otherwise, we can keep the questions after this.
Yeah, okay. We got no questions in chat or on the Q&A yet, Gareth.
Okay, great. Okay, so yeah, the scanning method then, this doesn't require any changes on your side, but because it's running from our systems, depending on the type of setup that you have, it can work very well in some cases, more towards the simple side of things. So where your pages are relatively static, the method to get to the payment page is very straightforward. That solution can work very well. For more complicated solutions, so this is maybe where you need to log in, where you have things like captures, for example, or where your page just changes very regularly, where you maybe have a high turnover of items that are for sale on your site, then our agent deployment is generally more suitable. So the more complicated the site is, the more suitable the agent is. John also talked about the blocking capability that we have to be able to restrict what that third-party JavaScript does. This only works for our agent deployment solution. So the agent here now is a single line of JavaScript that you add into your website, goes onto the payment page, and then that runs within the customer's web browser. And it allows us to see all of those behaviors, all of the changes, all of the differences that there might be. If you have multiple different payment service providers, for example, it will pick up all of those. If you have some sort of geolocation, geographic differences on your site, it will pick up on all of those as well. So this now, what I'll be showing you is kind of the agent deployment, but actually the dashboard that we see here is very, very similar between both the agent and the agentless solution. So if we start with the vendor services here, we can see there's two different vendors that we have in here. So we have Stripe as one here. This is a brand new piece of JavaScript that's been added. And then we also have something called Full Story. This is something that we've modified ourselves to add in a skimmer into that third-party library. So just to show you the process here, if we go into view details, then we can actually see exactly what's going on here for that third-party JavaScript. So we can see there's a network transfer that goes on. We can see that it's sending data to the PSP in this case. We can see the iframes that are being loaded here. And then we can also see the form fields that are being displayed here as well. So this is all kind of exactly as you would expect. You can see, there's an iframe coming down, form fields for the cardholder data, and then it's being sent to them for authorization. So if you were happy with this, you'd follow your process for authorizing any third-party JavaScript here. You can simply go to authorize. And then you can see here, because we recognize many third-party JavaScript vendors. So we have some pre-written justifications that you can use. Equally, you can just turn that off and write your own one here. And then we have a number of behaviors and a number of permissions. So by default, we recommend that people only allow the observed behavior. In this case, it was that data transmission to the acquirer. In this case, what we're saying here is that provided it only does what we saw there, so in this case, sending data to js.stripe.com, that is considered to be what's expected, and that's considered to be okay. If those behaviors change for any reason, then web page integrity will detect that change, and then it will come back out. It will say that it needs a reauthorization, a revalidation by yourselves, and you go back through this similar process to revalidate it. There are a couple of other options as well here. So we have the option to allow all of that behavior. So again, to John's point earlier, if you trust Elavon, for example, implicitly, you could choose to allow everything that script is doing. So you could choose to allow all, and then in that case, that script is just implicitly trusted. It doesn't matter what that script is doing, that is allowed to continue. We sometimes see this be used as well in cases where the entity has a completely different process. So for example, with first-party JavaScript, some companies will simply have a very different process for authorizing that script and making sure that all of its behaviors are as expected. So again, there you might want to trust it implicitly and allow all of that behavior. And then finally, there's a block capability. As I mentioned, this is only available in our agent. But in this case, what it will do is it will prevent that behavior from being allowed. So our JavaScript is kind of hooking into the web browser's functionality, and it prevents that script from being able to carry out this particular behavior. But for purposes of this, we've looked at the behaviors, we've seen them, we're happy with them. We're happy with our justification here, and we hit save. In this case, that has now gone through, that is now authorized. So we know now that the script is authorized, we have our justification, and if the script behavior changes, that assurance that we have of the script's behaviors, that has changed, and then it would come back out again for us to reauthorize it. If the behavior stays the same, so even though the script may change, provided that behavior stays the same, you won't need to reauthorize that script. I'll just mention here as well, we did some research recently with some of our existing customers to see what level of reauthorization they need to go through from a behavior-based approach, like web page integrity here, compared to a change-based approach, so something like content security policy, where that requires reauthorization anytime the script changes. And we actually found it was around about a 90% reduction in authorizations. So basically what that means is that scripts that our customers were using in their real world environments, there'd be approximately, for every 10 changes that were occurring, 9 of those didn't affect the behaviors of the scripts. And in one case in 10, it would change the behavior, and it's only that 1 in 10 that would need a reauthorization using web page integrity. So you can see both from the number of reauthorizations and really just in terms of how straightforward it is to authorize something, it does really reduce down the amount of work that you need to do here. So next, we're going to look here at full story. So this, as I mentioned, is something that we've modified to add in a potential skimmer. You can see it's very loud about the fact that there's a potential skimmer. And if we go in here to look at the details, we can see, first of all, in our history here, that this is something that's already been authorized in the past. So about 8 days ago, John F came in, he authorized this, it changed from needs review into the authorized state. And then 3 days ago, something changed. Web page integrity detected a change in the behavior, and so it switched it from authorized back into this needs review state. You can see here from a script's perspective, this is the script that it's picked up that has a potential skimmer. And if we look at the behaviors now, we can see a bit more about what's going on. So we can see here, first of all, that this script is actually sending some data out to maliciousAPI.thirdpartydomain.net. So this is where our script, our modified script, is sending data. It's the exfiltration out by the attacker here. There have been some additional changes to the full story script. And also there's an iframe that the attacker has managed to add. So in this case, something is coming from media.jscrambler.com. This is actually our CDN for our example e-commerce store. And the attacker has managed to get onto there and has put an iframe page on there that's now being loaded into our script, onto our page. And finally here you can see what the script is doing is the script is accessing cardholder data. It's also accessing the city for some reason as well. But in this case, full story as a script is something that just looks at analytics. So it's a lot like Google Analytics and other scripts that are like that. In this case, it's been modified to add in this, this ability to capture cardholder data and to exfiltrate it. So in this case, if you detected this, you would be looking at what you could do. You'd be looking at how you can remove this script, whether you can remove it, whether you need to roll back your website and so on. But in the case of using web page integrity, if you're using the agent, we have this blocking capability. So in this case, because we've recognized it and because we see that there's a potential skimmer that's found, the recommended behavior for all of these is to block. So if we block all networking, this will prevent that full story script from being able to exfiltrate that data out to maliciousAPI.thirdpartydomain.net. It will prevent it from being able to access the cardholder data, the card name, cardholder's name, the number, the expiration, the verification code there, blocks its ability to access that. And it blocks the ability to load the attacker's iframe that they're overlaying over the payment page. And if we hit save here, the process is slightly different here, but all we need to do is we click apply. confirmed that, and it's now rebuilding our agent. It rebuilds the agent, including the rules that we've just set to block those capabilities. It deploys it into our CDN, and then it's immediately available for our customers to use. So every customer has their own agent. In that case, it took, what, 6 or 7 seconds thereabouts for it to deploy that agent, and that would then be there protecting and blocking that payment page, whilst you as a company were still continuing with any kind of incident response that you're doing to get your payment page back into a known good state. So that's pretty much it for requirement 643. For 11.6.1, I've just been logged out. Bear with me 1 second. So for HTTP headers, the process is really very similar here. We're looking at security impacting headers. These are the ones that have been detected on our page, and the process is pretty much the same as we just saw. We can go to review, we can see what the header is, and then we can choose to either authorize it or to discard it. Authorizing it, hitting save, that's it, the job's done. So in this case, provided that header doesn't change, that is considered to be normal behavior, everything is good, and so you won't get a further notification. If the header changes for any reason, you'll get a notification and you'll go through this process again to authorize it. So it's very, very straightforward. The final thing I just want to touch on very quickly, as I'm conscious of time, is from an integrations perspective, we have the ability to send out emails anytime these changes are detected. For those of you who are using Jira, we can integrate with your ticketing system there, so we can open a ticket, and once the authorization takes place, we'll record that within the ticket and close the ticket automatically. We can post into Slack, so we can post into a channel of your choosing, or for just about anybody else, we can use webhooks as well. So we can post to a webhook endpoint, and then you can simply use your existing tools, your existing processes. You can use your own alerting, however it is that you want to do that. And this works really nicely with any logging systems, any other chat systems that you might have, and so on. So it's all pretty straightforward. That's pretty much it from a demo point. So at this point, I think in the interest of time, we'll stop here and I'll hand back over to Andrew for our Q&A.
Cheers. Thanks a lot, Gareth. Thanks, John. Yeah, a couple of questions there in the chat. The first one, will a recording of the webinar be available? Yes, it will. I'll send out a copy of this after when we're finished here, along with a bit of documentation as well that you might find useful. Perhaps a more interesting question is, how does Jscrambler integrate with my payments page? I assume you're offering it in an SAAS product, GDPR, and for implementing the protection mechanism, you need to be included as a JavaScript.
Yes, so there are 2 different ways of implementing, as I mentioned. So that the agentless method is a scanner that doesn't require any changes to your payment page, but it does require that path to the payment page to be relatively static. So we need to be able to get to that page. That runs weekly by default. So it just needs to be able to get to your payment page and examine it. The alternative method of implementing is using the agent, and that is a single line of JavaScript that gets added. It loads asynchronously, which means it loads in parallel with the rest of your site, and so it doesn't slow it down in any noticeable way. And it's a very lightweight agent that we have, so it's relatively straightforward to do. You mentioned GDPR there as well, Andrew. So yes, from a GDPR perspective, we are not collecting any of the data that is in any of those form fields. All we're doing is we're collecting information, so telemetry essentially, on the behavior of what's going on those pages. The only piece of information that even could be considered to be personal information from a GDPR perspective is the IP address. We're obviously using that when the agent is running, but from a logging perspective, we're actually masking that. We're truncating it. We're getting rid of the last octet of the IP address. So it's just the first, the general location, I guess, of the IP address that we're storing. So there's no personal information whatsoever that we're storing. And finally, Jscrambler is a company that's based in Portugal. So again, from a GDPR perspective, we're also bound by GDPR as a company. So the privacy policy very much aligns with GDPR from that perspective too.
And just to follow up on that, someone else, the agentless method, that cannot block scripts. Is that correct?
That is correct. Because it's running from our systems and it's not running within the page of the customer, when the customer is on the payment page, we simply don't have that capability. It needs to be running within the customer's web browser on that payment page for us to be able to block.
Perfect. And one for you, John, as well. Sorry, go ahead.
It's just that the core point is that the requirement doesn't require you to block scripts. So it's just for clarity that blocking scripts is a great thing to do for a security perspective, but it isn't part of the PCI DSS requirement, because when we wrote 643, there was only Jscrambler around that could do that, and we didn't want to give a monopoly to one company.
Another question, I think, for you, John. You mentioned iframes in the flow chart, but what about redirects to hosted payment page? The only script connected to the payments in our pages then would create the order and redirect to the HPP. They're not third-party scripts. Do they need to be monitored in any way? And if we have many other third-party scripts in the web page but are not connected to the payment, they don't need authorization. Would that be correct?
That's correct. If you look at the applicability note in requirement 6.4.3, it does not mention redirects. And the FAQ also talks about the fact that it doesn't. I'm going to check with Gareth that that's right, because it changed so many times. The 1588 also says it doesn't apply to redirects, or is that? Yeah, 1588 says that's right.
Yeah.
Right. From a security perspective, do you want to have control of the redirects on that page? I would advise you to do that. PCI DSS doesn't require you to do that.
I would just add as well, so to some of the confusion that you were just talking about there, John, the SAQ A, the one that was updated in January, talks about the site.
Yeah.
And there was some confusion for around about a month until the FAQ was published, 1588, that clarified it. So yes, it talks about the site in the SAQ, but when you include the FAQ with it, that then goes back to the previous kind of status quo where the redirect is not something that you're required to protect. But yes, it is very much a good idea.
Yeah. Although technically the FAQ is only informative and doesn't alter the standard or the SAQ, technically. Correct. But I wouldn't get that picky. If you have a redirect, I mean, I would be really careful about the redirect scripts you've got. I mean, I would do some protection on the script that does the redirect itself, because there have been a lot of it. There have been attacks against redirects. There have been frame overlay attacks where the criminal puts a frame before the redirect happens, and then says, oh, there was a problem with authorization, you now need to again, and then the redirect goes to the hosted payment page. So you're not immune to being skimmed, but you're in a better place than someone who's hosting a payment page on their own website.
Another very topical question, actually. Does Jscrambler use some auxiliary databases, for example, open source database of known domains that are related to MageCart attacks to detect malicious connections?
Yes. We do a few things, actually. So we look for indicators of so we have behavioral monitoring for a start, but we also have IOCs of all types of MageCart behavior. So we look at every piece of JavaScript to say, does it implement any of those IOCs? One of the problems we're looking for IOCs is most JavaScript is obfuscated, so you have to deobfuscate it first. We do that offline. So based on the telemetry, we do that offline. Because you can't do that in the browser in real time. That's why behavioral monitoring works really well. And yeah, we use databases of trusted domains and untrusted domains.
Perfect. And one thing for Gareth, can you limit the ability to authorize scripts to a subset of users in the solution?
Yes, absolutely. It's really quite fine-grained, the controls that you have. So if you were to use Jscrambler as part of that onboarding process, we determine what roles you need. It will map into any kind of single sign-on that you might have as well, so we can integrate with your roles and responsibilities and so on from that perspective. You can have read-only access and you can have read-write, and it is very, very flexible in terms of who can see what. Also, for anybody who has multiple sites that they're looking after, you have the ability to limit just to individual or specific sites, or the whole site as well. So all sites in that case. Yeah.
Perfect. And one final question, probably for yourself, John. Does it matter who your payment service provider is when it comes to these specific requirements?
I would have said traditionally, no, it wouldn't have mattered, Andrew. But now, because of FAQ 1588, and that you have two different ways of being able to determine whether your site is is susceptible to script attacks. One is to do 643.11.6.1, and the other is to get assurance from your PSP, then yes, it does matter who your PSP is, because you want a PSP that will give you that assurance that their e-commerce iframes are not susceptible to script attacks.
And just to clarify for anyone who's using an Elavon gateway, yes, we have the certification in place in there. So if you've validated with the Elavon solution, I can confirm that is in place with ourselves. And sorry, just one more question there as well. Is the license considering the number of sites?
Right. So the way we do our licensing at Jscrambler is based on the number of payment pages. And what that means is that if you have, for example, multiple sites, but it's all the same site, essentially. We have, for example, airlines who operate in multiple different countries. So you might have a .co.uk, a .es, a .ie, a whatever it might be. Lots and lots of different sites around the world. But underneath it all, it's the same site. We would classify that as a single payment page. Alternatively, if you have different sites where they're different code bases, we've worked with companies, for example, who will, they're a group, but they're made up of very disparate companies. Every single site is a completely different code base, very, very different, might be completely different technologies. In those cases, those would be different payment pages, and so we would classify those differently. So those would be separate payment pages in that case. The reason for this is because of the way that we're doing our monitoring. We will group everything together where it is the same site or the same payment page. So if it's the same payment page, we expect those behaviors to be the same. We expect the headers to be the same. If the reality is that you're saying, well, it is the same site or the same payment page, but really they're quite different between them all, it's often much better to separate those out, because otherwise you'll be getting alerts to say, we're detecting this behavior. Now we're detecting that behavior. Oh no, the first one is back again. And it can be very, very difficult to actually manage that. So we very much want it to be, the payment page is the same code base running the same sort of JavaScript. We can handle variations in that JavaScript, but really essentially it is the same payment page with the same headers. So that's how we do it.
Perfect. Thank you. I'm conscious we've gone slightly over the time there, so I think we're going to wrap it up there. Gareth, John, thanks so much for your time and for your presentation. Some really, really interesting stuff there. For everyone on the call, a recording of today's session will be available for you. I'm also going to pass on our PCI payment page analysis and the Elavon and Jscrambler solution brief after the webinar. A lot of the topics that John and Gareth have gone through today are explained in more detail. Of course, if you have any questions or queries, feel free to reach out to me directly. My contact details would have been on the invite as well. And I can arrange a follow-up with Jscrambler. They can go through any and all of your questions and requirements on that standpoint. I'd be happy to do an introduction or a call to go through and see how well they can do to help you become PCI compliant. Thank you all so much for joining today. Really, really appreciate that. Anything at all, just reach out to me directly and enjoy the rest of your day.